So in this session, we will move on to the last unit, that is differential equations. To understand this differential equation unit, you need little bit of knowledge of differentiation and integration, right? So what is differential equation? First, say what is equation? Equation is a function, or it is a relation between constants and variables put in a relative form using the symbols positive, negative is equal to. Say ax plus b is equal to 0 is what? It is an equation. So this equation involves algebraic terms, correct? So we will say it is an algebraic equation. Jx plus by plus c is equal to 0. It is algebraic quadratic equation, right? Suppose if it is involving trigonometric functions, sin x minus 1 is equal to 0. What do you say? This equation consists of trigonometric functions, so it is called trigonometric equation. It is algebraic equation. This is trigonometric equation. Suppose if it is having in this form a e to the power of x plus 2 is equal to 0. So this equation consists of what? Exponential terms, right? So exponential terms are involved. So it will be called as what? It will be called as exponential equation. So this is the meaning of an equation, which are different types. Then based on that, we can define differential equation. What is differential equation? It is an equation which involves constants, variables. Along with that, there will be a differential coefficients. An equation involving constants a, b, c, etc. Variables, that is x, y, theta, t, etc. and differential coefficients. Which are differential coefficients? D by dx, d square by dx square, d cube by dx cube, etc. If any equation involving this, either d by dx or d square by dx square or d cube by dx cube or both, such equation is said to be what? Differential equation. An equation involving differential coefficients is said to be differential equation. Shortly, we call it as DE, differential equation, right? Example, dy by dx plus y is equal to 0. X dy plus y dx is equal to 0. D square y by dx square plus 2 dy by dx minus 5y is equal to 0. So it is a differential. D by dx, dy by dx, we can reduce it to differential form, correct? Dy by dx becomes what? In x by y or y by x form. So it is also differential equation. They are all differential equations, right? They consist of differential coefficients, right? Then order and degree of differential equation. Order and degree of differential equation. See this is what? It is a linear equation. Suppose if it is ax square plus bx plus c is equal to 0, it is a quadratic equation, correct? Ax cube plus bx square plus cx minus 3 is equal to 0 or d is equal to 0. It is what? It is cubic equation. How we say? We say on the basis of x power, right? X power is 3, cubic, x power is 2, quadratic, x power is 1, linear. So they are said to be what? Degree of the equation. In the same way, here also, if we consider any differential equation, it consists of different ordered derivatives. So different ordered means what? dy by dx is first order. D square y by dx square is second order, correct? D cube y by dx cube, it is third order. This is first order, second order, third order. So based on the order, highest power of the derivative, we will say the order of differential equation. So order means what? Order means highest order derivative, highest order derivative in a given differential equation, that is said to be order of differential equation, right? Order means what? dy by dx. If the equation is having only dy by dx, say its order is what? First order, say order is 1. If the equation is having dy by dx as well as d square y by dx square, what is its order? Highest derivative is what? D square y by dx square. So its order is 2. Like that, we define order of differential equation as highest order derivative given in the differential equation is said to be order of differential equation. Then degree means power to highest order derivative, or we can say highest power to highest order derivative. Degree means what? Highest power to highest order derivative, in which the equation should be free from radical power as well as fractional power. They should not involve root of, they should not involve power of 3 by 2, 1 by 2, like that. So this is called fractional power, this is called radical power. Say they should not be involved in the given differential equation. Then we will take highest power to the highest order derivative will be called as degree of differential equation. Got it? Order means highest order derivative. Degree means highest power to the highest derivative. But what is condition? That equation should be free from fractional power, radical power. Root should not be there, and this power, fractional power, should not be there. Right? Let us take the example. Of getting order and degree of differential equation. Take the first equation. What is order and degree? The equation involves only dy by dx, correct? It is having only dy by dx. So order is 1. Degree is 1. Why? Only dy by dx is there. What is its highest power? It is 1 only. Therefore, order is 1, degree is 1. If you take this is also only in dy by dx. So order is also 1, degree is also 1. If I come to the third equation, see the third equation involves what? D square y by dx square, dy by dx. Two derivatives are there. This is first order, this is second order. Which is highest? second order is highest. Therefore, order is equal to 2, degree is equal to, what is power of this? Whole power is what? Whole power is 1. So degree is 1. Order is 2, degree is 1. Next, when we come to the fourth equation, see the fourth equation, this is having dy by dx as well as d square y by dx square. Dy by dx first order, d square y by dx square second order, which is highest derivative second order. Therefore, what is order of differential equation? Order is 2. What is degree? See, degree, don't get confused. This is first order having power 3, which is greater, but we should not consider it. Why? We should take highest power to the highest derivative. This is not highest derivative in the equation. Which is highest derivative? This is highest derivative. Therefore, whose power should be taken? What is its power? Power is 2. Therefore, degree is 2. Next, fifth example, d square y by dx square or d cube y by dx cube minus 3 d square y by dx square whole square minus 2 dy by dx whole cube plus y is equal to 0. What is order? It is having first order derivative, second order derivative, third order derivative. Which is highest? Third order. Therefore, order is what? Order is 3. What is degree? Degree means highest power to the highest derivative. Which is highest derivative? Don't look into these two because they are lower derivatives when compared to this. This is third order, this is second order, this is first order. Which is highest order? Third order. Whose power is to be considered? So degree is 1. Right? Let us take some other example which are having radicals and fractional powers. One plus dy by dx whole square whole to the power of 4, sorry, 1 by 4 is equal to d square y divided by, sorry, d cube y by divided by dx cube. As I mentioned that to get order, we should check which is the highest order derivative, right? So highest order is what? It is first order, dy by dx, even it is not even second order. The power is for whole power. So this cannot be considered as second order, right? This is first order, this is third order. So order can be taken as what? No doubt, order is 3. While saying degree, we should remove the fractional power, right? What is fractional power? 1 by 4 is fractional power. How to remove it? How to remove it? Take power of 4 on both sides. Take power of 4 on both sides. If I take this 1 plus dy by dx whole square whole to the power of what? 1 by 4 whole to the power of 4 is equal to d cube y divided by dx cube whole to the power of 4. I have taken power 4 on both sides. Now, this 1 by 4 and this 4, they get cancelled. How? A to the power of m to the power of m is equal to a to the power of m into n. If I multiply 1 by 4 into 4, m into n, 1 by 4 into 4, 4 get cancelled. What is remaining? 1 plus dy by dx to the power of 2 is equal to d cube y divided by dx cube whole to the power of 4. Now say degree of differential equation. This is having highest derivative 3, third order differential equation. What is its power? 4. Therefore, degree is equal to Degree is equal to 4. Right? Next one, root of 1 plus dy by dx whole square is equal to d square y divided by dx square. So this is fractional power, correct? This is called fractional power that we have to remove first before saying order and degree, right? This is what? Radical power. Radical power. The root is there, right? How to remove the root? You just square on both sides. If I square this, root of 1 plus dy by dx whole square whole to the power of what? 2 is equal to d square y by dx square whole to the power of 2. Just I have squared on both sides. This square root square get cancelled. What is remaining? 1 plus dy by dx whole square is equal to d cube, sorry, d square y by dx square power 2. Then we can say order is what? This is first order, this is second order. Which is highest? 2. Therefore say order is 2. What is degree? What is degree? We should take the highest power to the highest order, right? Degree is also 2. This is the way of getting order and degree of differential equation, right? Now let us take types of differential equations. There are two types. One is ordinary differential equation. Types of differential equation. One is ordinary differential equation. Other one is partial differential equation. So ordinary differential equation means this is equation obtained with only one variable. Only one variable. So it is always with respect to x, this dy by dx, d square y by dx square. So it will be like that only. Partial differential equation means it depends more than one variable. More than one variable. Say like this, d square y by dx delta x delta y. It means it is differentiated once with respect to x and again same will be differentiated with respect to y. So that is called as partial differential equation. d cube y by dx cube. Like that. So it is a partial differential equation. So we are not interested in the partial differential equations. So it will comes in higher mathematics. Now we are only restricted to the ordinary differential equation. Right? In the ordinary differential equation, suppose the equation is in this form. It is second order differential equation. Why? It is having highest order is 2. But we are interested only in the ordinary differential equation of first order and first degree. First order and first degree, right? So let us take how to form this differential equation. So we got the definition of differential equation and we got examples of differential equation. Then we learned what is order and degree of differential equation and how to find out order and degree of differential equations. Right? Then formation of differential equation by eliminating arbitrary constants. What is meaning of arbitrary constant? In constant there are two types. Constants are two types. One is absolute constant. Another one is arbitrary constant. Absolute means it is fixed, whose value cannot be altered. That is called absolute. Say example, the value of pi is constant. The value of gravitational constant, like that they are what? It is absolute. If I say distance between Bangalore and Mysore, if it is 130 kilometer, say which will be said to be what? Absolute constant. Then ordinary constant means, so it is a constant which can take different values. Say if I take number of desks in a classroom or A. So I don't know the value of A. A may be 5, A may be 10, A may be 15. That will be called as what? It will be arbitrary constant, right? Suppose if I take distance between two places, if it is K or M kilometer, I don't know the M. So M is a constant, no doubt, but it can take different values. If I change the places, the value of distance also changes. Such constants are called arbitrary constant. Okay. Formation of differential equation by eliminating arbitrary constants. This is one method of getting differential equation. So they will be given a function y is equal to f of x is a function which involve constants, arbitrary constants will be there, right? Then how we should get differential equation? What is differential equation? It is an equation which involves d by dx or d square y by dx square or d cube y by dx cube. How you will get dy by dx or d square y by dx square? It is only available after the differentiation, right? If you differentiate once, you will get dy by dx. If it is again differentiated, you will get d square y by dx square. You do one time, this is second time. If I again differentiate it successively, you will get what? Third order differentiation. Correct? So first point is to form any differential equation of any curve like this, y is equal to f of x, we should differentiate. How many times you have to differentiate successively? So it depends on number of constants. So we seen that some equation is having only dy by dx, some equation is having d square y by dx square and dy by dx. So how you will get d square y by dx square? It gets only after differentiating a function two times, right? Twice. Second order differential equation. So for any curve, the differential equation is obtained differentiating the given function as many times as that of number of arbitrary constants, right? So this is first point. To take any function, how to form a differential equation means we need to differentiate it. How many times? As many times as that of number of constants. Suppose if it is having one constant, then we should differentiate once, right? If there are two constants, we have to differentiate how many times? Differentiate twice. If there are three constants, we have to differentiate it thrice, right? So after differentiation, do you think constants will be eliminated? In some equations, in some function, after differentiation, constant will be eliminated immediately, right? For some equations, constant will not be eliminated even after differentiation as many times as that of constants. Then what to do in this second case? If it is removed or eliminated after differentiation, well and good. So that will become differential equation. If the constant or constants are not eliminated after differentiation, then we have to go for substitution method. We have to substitute for constant either from derivative to function or from function to derivative. So this is the procedure you need to follow to form a differential equation. What is that procedure? First, see the given function, identify the arbitrary constants. If there are two arbitrary constants, then you go for differentiation twice. If it is only one is having, so then differentiate once, right? After differentiation, you check it, the derivative. If constant is removed or eliminated automatically, then you can express in the differential equation form. If it is not, then you go for substitution method, right? Let us take an example of formation of differential equation. Question will be like that: obtain or form the differential equation of the following functions. By eliminating arbitrary constants. Right? Let us take one by one. Number one, x square plus y square is equal to a square. So this is an important problem. X square plus y square is equal to a square. See, this is a function whose differential equation is to be derived, right? How many constants are there? First identify. Only one constant. So constant is what? The constant is a. Then how many times we have to differentiate? Differentiate once, because it is having only one constant. Differentiate this. We know the differentiation. Differentiation of x square is 2x plus differentiation of y square. It is y term. Differentiate similar to x term, but at the end we have to put dy by dx is equal to differentiation of a. A is what? Constant. Differentiation of any constant is 0. Now say, look at the derivative. Do you find constant further? No, right? So this will be the differential equation. So it may be reduced to other forms or in the differential equation form. This is also differential equation, but we use regularly like this: 2y dy by dx is equal to what? Minus 2x. 2 to cancel. Therefore, dy by dx is equal to minus x divided by y, or it is dy by dx, take this side, plus x by y is equal to 0. This may be the one of the form, or this may be the another form, or from this we can write like this: y into dy, y into dy is equal to minus x into dx. Or you take this side, minus x become plus x dx plus y dy is equal to 0. So in these forums, you can write or you can mention any one forum, right? See, after differentiation of one time, the constant is eliminated automatically. Let us take second example. Sin inverse x plus sin inverse y is equal to a. What is constant? A is constant. How many constants are there? One constant, right? So differentiate once. Differentiation of sin inverse x is what? It is 1 by root of 1 minus x square. Differentiation of sin inverse x is what? It is 1 by root of 1 minus y square into dy by dx is equal to what? Constant. Differentiation of constant is 0. Right? See, after differentiation, constant is eliminated automatically. Then this will be called as differential equation. Right? You can reduce it to other forms also. 1 by root of 1 minus y square into dy by dx is equal to cross multiply this. Send dx this side, dy divided by root of 1 minus y square is equal to minus send dx to right side. So it goes to numerator because here is in the denominator 1 minus x square. So this is also a differential or that to left side, so it plus dy by dx divided by what? Root of 1 minus x square is equal to 0. Or you can write in this way: dy by dx is equal to so this goes to numerator dx is equal to minus of whole root of 1 minus y square by 1 minus x square. So this is the differential equation, right? Third one, 1 by x, or you can take log x plus log y is equal to a. Log x 1 by x. For differentiation of log y, 1 by y into dy by dx is equal to 0. See, constant is eliminated. So this will be the differential equation. Or 1 by y into dy by dx is equal to minus 1 by x. Otherwise, d is into this form. You just send to the y is sent to the other side. It goes to numerator minus y by x. Or you can write x into dy is equal to minus y into dx. Or x dy plus y dx is equal to 0. Fourth one, y square is equal to 4ax. How many constants are there? Y square is equal to 4ax. 4 is absolute constant. Don't consider it as constant, right? Only a is considered as arbitrary constant. How many constants are there? A is constant. Then how many times you have to differentiate it? We have to differentiate only one time. See this. For y square it is 2y into dy by dx is equal to 4a into differentiation of x is what? 1. For one constant, they have differentiated one time. See, the derivative constant is eliminated or not. Constant is still in the derivative. Then we should go for substitution method. Right? How to substitute it? From where to where we have to substitute? You can substitute 4a value from the given function is what? Y square by x in this derivative. Or you can take 4a value from the derivative and which should be substituted in the given function. In both the way you can do it. Right? No problem. Take this is equation 1. This is substitute x from 2 in 1. What is 1? Y square is equal to 4a x. Therefore, y square is equal to 4a. What is 4a? 4a is equal to 2y into dy by dx into what is x? X is taken as it is. See, after substitution, do you find constant? We don't have constant at this stage. So this will be treated as what? It is free from arbitrary constant. So we can simplify it. Y cancels. So y divided by 2 into x. 2x is equal to dx. Cross multiply it. Y into dx is equal to 2x into dy. This can also be called as differential equation. Got it? Sometime after differentiation, constant will be eliminated automatically. Suppose if it is not eliminated automatically, or what? Substitute it. It is separated from the given function and it is substituted in the derivative, or from the derivative you can substitute in the function. Right? Next question. Y is equal to C into tan inverse x. Y is equal to C into tan inverse x. What is constant? C is constant. C is constant. How many constants are there? Only one. Then we have to differentiate. How many times? So differentiation is also carried out only one time. Right? Differentiation of y is what? Dy by dx. C into differentiation of tan inverse x. 1 by 1 plus x square. See the derivative. Differentiation is over. Do you find constant? Yes, it is still in the derivative. Then what to do? You take function. What is function? Y is equal to C into tan inverse x. Or C is equal to, separate C from here. C is equal to what? Y divided by tan inverse x. You just substitute in the derivative. Okay. What is derivative? It is dy by dx is equal to, what is C? C is equal to y divided by tan inverse x into, after C we have 1 by 1 plus x square. See, here we don't have constant, right? This is differential equation, or dy by dx is equal to y divided by 1 plus x square into tan inverse x, or you can cross multiply it. 1 plus x square into tan into dy is equal to y into dx. This is called formation of differential equation of the function having only one constant. Right? Now let us take the function having 2 or more constants. y is equal to a e to the power of mx plus b e to the power of minus mx. Y is equal to what? A e to the power of mx plus b mx. How many constants are there? Don't think m is constant. It is not absolute arbitrary constant. It is absolute constant. Let it be a and b are constants, right? How many constants are there? 2. Then we have to differentiate. How many times? We have to differentiate 2 times. Differentiate twice, right? Differentiate y with respect to x. What you will get? Dy by dx. So dy by dx is equal to a into e power mx. A into e power mx. Differentiation of a into e power mx. Keep a as it is. Differentiation of function e to the power of function, right? For e power x, it is e power x. For e power function, it is e power function into d by dx of function, right? Plus keep b as it is. Differentiate e to the power of minus mx. It is e to the power of function into d by dx of minus mx. For e power x, it is e power x only. For e power function, it is e power function into d by dx of function, right? A into e to the power of mx. Differentiation of mx is m into 1, right? Plus b into e to the power of minus mx. Differentiation of minus mx. Minus m is constant into differentiation of x is 1, right? It is m into a into e to the power of mx plus into minus minus m into b into e to the power of minus mx. So one time differentiation is over. Again differentiate this. Again differentiate with respect to x. Then we will get what? D square y by dx square. That is equal to, keep constant as it is, m into a. Differentiate e to the power of mx. E to the power of mx into differentiation of mx. You can write directly. So d by dx of mx is what? M into 1. Minus, keep m into b as it is. Differentiation of e to the power of minus mx is e to the power of minus mx into differentiation of function minus m into 1, right? This m into 1 into m, it is m square e to the power of mx minus into minus plus m into b into mx. We different times. Okay. Do you find constant? See, at the end of the second order derivative, still constants are there. They are not removed. So then what to do? We have to remove by substitution method. How to substitute? What to substitute? See, check the derivative. M square is common. You take m square. What is remaining? A into e to the power of mx plus b into e to the power of minus mx. Observe the bracket and the given function. Both are same. So a e to the power of mx plus b e to the power of minus mx is given as y. If you take this is y, substitution, we are taking this bracket as y. So constants are eliminated. So this will be the answer. Same question we have done in the successive differential equation. There they will give the function, they ask find the second order derivative. So this is the method we followed there. Same thing we have to follow here also. Okay. Next. Sometimes they will give you like this: x into y is equal to a e to the power of x plus b e to the power of minus x. How many constants are there? 2, a and b. So this sixth problem, so problem 1 and the same, but here we have xy, right? Only y is there, but here both x and y is given. M is not there here. M is not there when compared to this, right? You follow the same procedure. First thing is identifying the constant. How many constants are there? A and B are constants. There are two constants. Then we have to differentiate what? Twice differentiation. Is it right? Twice differentiation. So on differentiating, how to differentiate left hand side? Left hand side is what? X into y. It is product of two variables. Then we should go for product rule. Product rule says first function into dy dx of second plus second function into dy dx of first is equal to a into e power x differentiation is e power x plus b into for e power minus x it is e power minus x into dy dx of minus x. So minus x should be considered as what? It is a function, e power function, right? It is equal to a e power x plus b e power minus x. Differentiation of minus x is minus 1. That is x into dy by dx plus y into, you can take here also, dy by dx plus y into differentiation of x is what? 1, right? Y into 1 is y is equal to a e power x plus into minus minus b e power minus x. Then again differentiate it. Again differentiate with respect to x. Left side there are two terms which are in sum, x into dy by dx plus y. How to differentiate this? We have to differentiate both the terms. If I take first term, it is again in the form of what? U into v, x into dy by dx, which is considered as product, right? So use product rule, x into dy by dx of second function v. What is v? It is dy by dx plus keep dy by dx as it is into dy by dx of what? X plus differentiation of y dy by dx is equal to a into e power x is e power x only minus b into for e power minus x. It is e power minus x into differentiation of minus x. Take it as minus 1, right? X into d by dx of dy by dx is what? It is second order differentiation. D square y by dx square plus dy by dx into differentiation of x is what? 1 plus dy by dx is equal to a into e power x minus into minus plus b into e power minus x. See, constant, two constants are there, we are differentiated 2 times. See, after differentiation of 2 times, we have still constants. Then we have to go for substitution method, right? See the right hand side. So right hand side is what? A e power x plus b e power minus x. It is in the problem itself. That can be taken as what? X, y. Then the problem become x into d square y divided by dx square plus 1 into dy by dx. It is dy by dx plus dy by dx is what? 2 times of dy by dx is equal to x into y. Sometimes the same problem will be given with y is equal to. In that case, you will have only y at the right side. y is equal to a into cos mx plus b into sin mx. Form the differential equation by eliminating arbitrary constants. Which are arbitrary constants? A and B are arbitrary constants, right? Identify the constants. A and B are constants, right? How many times you have to differentiate? There are two constants, we have to differentiate twice, right? Differentiate twice. Therefore, y into differentiation of y is what? dy by dx is equal to, keep constant as it is, differentiation of cos, it is minus sine into mx into differentiation of mx, right? Plus, keep the constant b as it is. Differentiation of sine is what? Differentiation of sine is cos mx into d by dx of mx. Differentiation of mx function, right? It is treated as what? Function. Cos function, sine function. For cos x, it is minus sine x. For cos function, it is minus sine function into d by dx of function, right? It is equal to minus a into sine of mx into differentiation of mx is, m is constant. For x, it is 1 plus b into cos mx. Differentiation of mx is what? M into 1, right? It is minus ma into sin mx plus m into b into cos mx. This is what it is, first order differentiation, right? Again, we have to differentiate because we have two constant. Again, differentiate with respect to x, that is d square y divided by dx square is equal to, keep minus ma as it is. Differentiation of sine function is what? Cos function into differentiation of function. What is function? Mx. Differentiation of mx is m into 1 plus m into b, constant, keep as it is. Differentiation of cos function. Cos function, it is minus sine function into d by dx of function, into d by dx of function, right? That is equal to m into m square. It is minus m square a into cos mx plus into minus m into m. Here also you can write directly the derivative of mx is m into 1, right? M into m square b into sin mx. Differentiation is over. Then make the simplification to replace the constant, right? Minus m square is common. You take it outside. What is remaining? A into cos mx plus b into sin mx. Observe the given problem. What is problem? Y is equal to a cos mx plus b sin x. Can you replace this as y? You substitute from the problem. It is minus m square y. D square y divided by dx square is equal to minus m square y. See, the constants are eliminated, right? Or it can also be written like this: d square y by dx square plus m square y is equal to 0. This is a second order differential equation, right? Y is equal to a into cos x plus b or cos of kx plus b. Check how many constants are there. We have two constants. A is one constant, b is other constant. K is not the arbitrary constant which is absolute. constant. Right? How many times we have to differentiate? We have to differentiate twice because a and b, two constants are there. Differentiate it. Dy by dx is equal to, keep a as it is. Differentiation of cos function. Differentiation of cos function is what? It is minus of sine function kx plus b into d by dx of function. What is function? Kx plus b. That is equal to minus a into sine of kx plus b into differentiation of kx, k into 1 plus b 0. It is minus ka into sine of kx plus b. This is first order differentiation. We have to differentiate twice, therefore again differentiate it. Again differentiate with respect to x. We get what? We get d square y by dx square. That is equal to minus k into a, differentiation of sine function. For sine x it is cos x. For sine function it is cos function into d by dx of function. So kx plus b is function, right? Minus k into a into cos of kx plus b into differentiation of kx, k into 1 plus 0. It is k only, right? This k and this k become what? Minus k square into a into cos of kx plus b. Differentiated twice. This is the second order differentiation. Constant, still constants are there. Then how to replace them? You see the question. What is question? Y is equal to a cos kx plus b. Here is also a cos kx plus b. Just replace it by y. So minus k into k square into y. See, constants are eliminated automatically. This is known as formation of differential equation, right? So based on the given differential equations, we can go for getting solution of the differential equation in the next class, right? So this is known as formation of differential equation, right? Do you have any questions? Please raise your questions.